Hey everybody, this is Larry. This is day 30th of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. I'm here in Naha in Okinawa in Japan on my last day in Japan, last full day anyway. So yeah, let me know what you think about the comment. Look, check out this temple, check out these beaches, or beaches. And also check out the sunset, I think, and the highway. All right, I think you checked out everything, so let's check out this problem. Let's go. Hey everybody, this is Larry. I actually did this live. This is a long video because it took me an hour and change to solve today anyway, because I don't know. Maybe I'm just a little bit off. I'm here in Falun in Taiwan. A lot of traveling, so I'm very tired. But I'll go over the explanation from this really smart guy I know from 4 years ago. I'm just kidding. But no. It's my submission from 4 years ago, and I think that code is actually more intuitive to learn. So I'm going to go over that instead of the code that I did today, which I kind of did a little bit of pattern matching and try to figure it out, right? Okay, so one of the key things to understand is that this is also a grade code, and what that means practically for this problem is that the minimal number of operations will go through every number in binary once, right? You can think about it as it's just, there's no branching out or anything. It deterministically goes from one to the other. Kind of. I'm hand waving a little bit. Do your own research on grade code because there's definitely a lot of nuance there, but that is some part of understanding. Okay, so basically one thing to kind of just play around with, and if you play around, you'll notice that if you have 1, it takes this number of moves to go to 0. If you have 10, which is 2, this number, you have 100, which is 4, 8. So that's the number of moves it takes to go to 0, right? And the reason why you can, and this is kind of relating to grade code because it has to go through all. I mean, that's one way to prove it. Another way to prove it, you just play around with it and kind of get an intuition of why that is the case. And the reason is kind of like roughly, let's say you have here, you have to go with here first, and to go to here, you have to go to here, and then, I'm skipping some of the steps, and then to go to here, you have to go to here, and then basically dot, and then eventually you hit every possible 2 to the, or the possible prefixes, right? Until you get to 1,000, and then you do it again. So if you sum it all up, or the previous steps up, you get 2 to the 5th minus 1 for 5 digits. Okay, so then now the problem is, how do you change it to 0? So given n, the way that, first is that I convert it to a binary string, or a string containing the binary digits. This is just for practical purposes, or laziness purposes. That's the practical purpose of just having 1s and 0s. There are a number of ways you can do it, but that's how I did it. And then here, we just want to change to 0 because that's the name of the problem. Change the things to 0, right? And what happens when you have 0? So you have to change all x to all 0. So then now, if there are no digits, you return 0. If there's 1 digit, then you have 2 moves, right? If it is a 1, then you make 1 move and turn it to 0. Otherwise, it's 0. If the first digit is 0, then you can just do the suffix, right? Because, for example, if you have, you don't have to worry about the prefixes, so you just chop it off and calculate the rest. Okay, and then now if this is not true, that means that now your prefix is a 1, right? And you have some random, I don't know why I wrote a, but like it can be any number combination between. And of course there are only 2 cases, which is that the next digit is a 1. If the next digit is a 1, then now to convert this prefix from 1 to 0, then you just have to convert the rest to a 0. So that's what this basically does, right? So you change this to 0, change the suffix to 0, you change all these to 0, and then now you have this number, and then you do, you make 1 move to remove this, right? I think I wrote it a little bit weird, but you make 1 move to remove the prefix of 1, so you get to here, and then you do 2 to the x moves, x minus 1, but you add 1 because you have to make that move, to get rid of this, and that's your answer, right? A little bit recursive, but that's fine. And of course, yeah, okay. Otherwise, you have something like this, right? From here, then your goal is to get to here. So then you can make these moves, the same thing as before. So here now you have changed to 1 of this prefix. So now you take this prefix and you change it to the first digit to 1 to convert it to 0. And then after this, then now you can convert this to the answer in 2 to the x moves. Again, same idea. And then now you have a change to 1 function, which is this is the thing that I couldn't get today, even though I got it 4 years ago, is to change to 1 function. So you basically, you change the first digit to a 1, and then the rest to zeros, right? So again, if there's no string, it's 0, no moves, you're done. Actually, maybe that's an infinity, I don't know. By the way, that doesn't come up, I think. Maybe I'm wrong. If there's length of 1, then you just have to do the one that change the moves. If the first character is a 1, then you just have to return the change to 0. So this is very recursive, very what I call exhaustive enumeration. You just go for every possible case. And now here, you have 0 because the first character is 1. You already handle that case. That means the first character is 0, and the rest is some random junk. And then now this is basically the idea, right? So then now the random junk, we convert them all to 0 except for the first one. We get this, and then we make one more move to get to this, and then now, wait, what? Oh yeah, this is changed to 1. So yeah, you make one move to get to this, and then now you make again 2 to the x moves or 2 to the k moves, I will here, to get rid of these to go to the suffix of 0, right? And this is the same here. If the second digit is 0, then you want to change the first digit to a, well, you just change all these to a 1, and then now that you're here, you make the same moves as here, and that's basically what this does. So yeah, I think this is a cleaner way to understand this problem. It's just recursion. And this is something that happens in gray code as well. So you basically just change 1 bit at a time. The way that I wrote this is technically n squared because we keep on allocating space and stuff like this. It makes this function O of n instead of O of 1. But you can also just keep track of an index, and that would be fine, right? Because we only look at the suffix, right? So like in the same way that you do dynamic programming. But yeah. But that's pretty much all I have for this one. This is, I think, a better understanding of the problem, or a better understanding of the solution. So let me know what you think. If done slightly more properly, this is linear time and yeah, linear space. Linear because n has log n bits, and we do this amount of recursion. Note that every time we do a recursion, we remove at least the first character, right? So yeah. Anyway, that's all I have for this one. Let me know what you think, and you can watch me in the live today in November 30th, the struggle that I did and try to figure out the pattern matching. I am just out of it. So yeah, let me know what you think, and definitely let me know if you have questions. And please, your question should not be "you can explain better." That doesn't help anybody, and you should know that. Anyway, I mean, I'm trying. All right, look. Anyway, that's all I have for this one, though. Ask questions here, Discord, and I'll see y'all soon. Thank you. Bye-bye. Or you could watch me solve it during the whatever now. Hey, everybody. This is Larry. Oh, yeah, there's an intro. But, yeah, day 30th of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I hope you liked the intro. I'm here actually now in Falun. In Taiwan, so yeah, let me know what you think. I'll have to so tired, so many flying and traveling. Anyway, today's problem is 1611, minimum 1-bit operations to make an integer 0. Given an integer n, you can transform it to 0 using any number of times. Change the rightmost 0. Okay, change the ith bit in the binary representation of n if the ith minus 1 is set to 1 and ith minus 2 is set to 0. Okay, let's think about what that means. What are the operations? So you have two operations. So change the rightmost bit. So here you have some number, and the first one is just change the last one from 1 to 0 or 0 to 1. Okay. And then the second one is change the ith bit in the binary representation if ith minus 1 bit is set to 1. And so if you have suffix like this, you can change it from 1 to 0 or 0 to 1. All right? Okay. Okay, that's interesting. Okay, so I mean, I think the first thing I'm going to do is play with small numbers and see if we can come up with something, just something to play around with, if nothing else. So you have 0 is 0, 1 is just going to, you change it to from 1 to 0, so that's 1. 2 is going to be, what do you do, right? So you have this, you're going to change the 0 to a 1, you're going to change this 1 to a 0, and then change this 1 to a 0. So is that 3? Right, I forgot I didn't count. So okay, so like this, 1, 2, 3. So that's 3, right? So 2 is 3, and then 3 is actually going to be this, and then you change I, change the, and then it's going to be 0. So that's actually going to be 2, right? Okay, so those are all the 2-bit ones. So what's 4? 4 we have this. Well, you're not going to make this a 1 because that doesn't make any sense. So, or I don't know, maybe it does for now. So this, you're going to go to 101 to 111. Change this, and then change this back to a 0, and then now you can move this to 10, right? And this is of course a 2. So, yeah, and 2 we have an answer for, which is 3, right? So this is this plus 3. Okay. And n is a big number, I guess. Yeah. What are we doing here? Well, it seems like this is what is that thing where you go through all the sequence from 0 to 1 once? What is that guy's name? I don't remember. It's been a long time. But there's a thing where you always change one bit and you can go for all the bits. And with this way, it seems like a naive first try, or at least mentally, is kind of what I did, right? Except for now, it's going to be like a breadth first search thing. Can you do this in reverse? What would be the reverse of this, right? 0, 1, add a 1, I don't know. Maybe there's a way to do it, but it seems very confusing. But okay. But it seems like, okay, so let's say 0 is 0, say 1 is going to be 1, but then 10 is going to be 3, 100 is going to be 7, right? Because now, in a way, this is always the worst case, right? This is the worst case, is because in order to remove this one bit, you have to basically convert, because, yeah, so to get from here, you have to get to here, right? I mean, yes, but what's a better way of thinking about it? Well, the way that you have to think about it is that 100 goes to 7 because it basically reaches all the other possible numbers before hitting the 2, right? So this should be 7. And 1,000 is going to take all the other numbers until, I mean, if I have to guess, this is going to be 15, but okay. So we have some pattern about this, but then now how do you do the intermediate stuff, right? We have some powers of 2 things. What which is fine. Assuming I'm not off by 1. Can we combine these? Like, okay, let's say we have, I don't know, 1, 1, 1, right? What's another way to decompose this? Well, we want to go to 1, 1, 0, which is actually the next one, but it may not be. I mean, okay. I have a feeling about it, but I'm still trying to figure it out a little bit how to do it. I'm trying to figure out if there's an easy way to decompose it using the things that we know, so we could kind of build recursively. Can I go to 1, 1? Do I need to go to 1, 1? Would that work? Is there well, I think there's like some recursive thing, right? So, okay. So let's say you have this 1, 1, 1. What are we trying to do? Well, we're trying to go first to 100. And to go to 100, we have to first go to 110, right? Because so that we can make this into a 0. And 110, first, we have to go to 1, 1, 1, which doesn't make sense. Hang on. This is really weird. I don't mean it like that. So 1, 1, 1, we want to go to 0, 1, 0, or maybe 0, 1, 1. What is the next logical jump? I think that's what I'm trying to figure out. Like, okay, let's say we have 1, 1, 1. We want to get rid of this number, right? The leading 0, 1. So that means that we have to go to at least this number. So that we could get a 110 and then remove it, right? Does that generalize? Let's say we have to do it. I mean, that's just a very particular example. Then what do we do? Then the next number that we're trying to do is, of course, 1, 1, 0, 0, 0, 0, whatever it is, matching, right? And then now we can remove the 1, and then we know what this is in theory. But before that, how do we zero these out? In what order do you zero these out? Let's remove a 0 for now. In this case, in order to remove this 1, we have to make this suffix 0s, right? And in order to make this a 0, we have to make sure that all these are, well, just 1, 0, 0, right? Can we add them up? Okay, so for example, the first thing we're trying to do is get to, I guess this is already good, because then, no, what am I doing? So we have to try to get to here. Right? then now, no, what am I doing? This is a hard one. I mean, because I think the way that I've thought about it is just pattern matching, but I'm trying to figure out a more logical way other than pattern matching. Because, for explanation, pattern matching is like a pattern. It's not very interesting. But I think there is something like this where you're like doing this inductive thing, but I'm kind of blanking out on it today. So to remove this one, we have to get to do, right? So how do we get here? Well, we get to here by first getting to here, right? Because if you get here, well, technically you get to here, and once you get to here, then now you could turn this off, and then now you could recursively do this, figure out the suffix. Is that it then? It's just one bit at a time? For example, if it takes 3, what was the suffix on this, right? So in one move, you would you don't do this, do you? No, because then, oh wait, maybe you do. Oh, in one move, now you 1 move, 2 move, 3 move, 4 move. And then you do the smaller ones. Wait, what is the first move? First move would be, this is kind of hard, right? You actually want to do, okay, do 1, and then now, oh wait, no, do you? No, you do this, and then now you do this, and then you do this, and then you do this, and then now you do this, and then now you have to change these to zeros somehow, and you know how to change these to zeros. This is a set number of sequence. Now you do this, and now you change this to a 0, and now you change this to a 0. These to 0 again. We could figure that out. It's like 2 to the 5th minus 1 or something, and then you have 0, right? And then now you have 0, and then now you do this. Okay, I think I get it. Maybe. Let me try again. I mean, I'm trying to like get it, understand it enough to be able to code it, right? It's not enough to like okay. So the first thing we want to do is and was that even minimal? I don't know. Alright, so and now you have this. What do you do? Well, now you go do this, and then now you can turn the suffix. Okay, you have a lot of moves. And now you have this thing, and then you can remove the zeros. Now you have this thing. Well, now you can remove this 0, but is that true that I can always remove these zeros? Am I making that up? No, I mean, it should be okay, yeah. It's the same as just this answer, right? Now you do this, and now you have this, which then you do this, and then now you do this. Still don't have a good formulation of it though. Why don't you do this and then why don't you just do this Oh no, you can't. I see. So then now you have the suffix. If it's this, then now you can turn this off. And then here you can turn these off. So I think the special cases if you have ones in a row. Maybe that's the part that I was confusing a little bit. Let's say you have a lot of ones, what happens? Well, first, you have to create a 0, so the only way to do it is going to be to do zeros. And now you have this, then now you can take this off, and then take this off. Well, I'm trying to think which one makes sense. Like, should I go, I mean, this is also logic the other way. Should I go here and then remove? Or is it just like remove, right? That's interesting actually. So let's say you have 1, 1, 1, 1, 1. Let's do a smaller example so I can kind of work it out what the best answer is, maybe. Right? Is it to go to do and then take, did I make that up? I didn't make that up, right? Because, well, then you go 1 and then you go 0 and then you go 0, right? And now you could do this. But you don't want to because you actually should take this off first. You could take the 0 and then this, right? Maybe I need to play around with the examples more. I think I'm not, my intuition is not very good. Okay, so then now let's say you have 1,000. 1,000. I just assume that you can go to the 1, right? And this is the sequence that we're talking about, and then right? And then now this goes to 100, which is this thing, which is +8 or +7, maybe, depending on how you want to count it. Is that right? I skipped a step, I think. This goes to do, and then now you do, and then this. Okay, that's why it was, well, it just looked weird. And then this is 100. So if we have something like this, we definitely do not take this off. Because if we take this off, so basically we always want to take the biggest digit off first. And the way to take the biggest digit off first is just by setting the second bit to I, and okay, I think I get it, but I still don't know the This is kind of hard. I mean, I think I understand the problem. I don't think I missed anything, but it's just a hard problem to reason. Let's say you start with here, right? Then now you want to get rid of this 1, so you're trying to get to, well, here. How do you do the moves? Also, I missed some steps. this actually goes to, that's why I got confused here. And then and then this. Okay. Wait, did I get everything this time? So let's say you're here, you want to get to here to get rid of this one. Well, that's not so bad. Well, let's say you have some random number, right? How do you do it? Well, we want to go to here, and you go to here by zeroing this out first. So that means that you want to go to this first. Man, I feel like I have no idea what's going on. What is that word I was thinking of? Named after that guy who plays up these kind of sequences. Hemming? Oh, I guess that was yesterday's thing, right? Hemming distance and the Hemming cycle, or whatever it's called. And of course, it can get very big. So given that n is very big, we cannot just simulate even. Well, I mean, simulate is not necessary. We know how to do like here. We just have to figure out how to get here. So if I wrote this wrong, but it's here. To get to here, you have to go to right? And to get to here, but like, what is the formal way of doing it? Or formal way of describing this? Is it just taking the last bit off one at a time? Like, okay, let's say we go here, right? That's not even true. You can't take this last bit up because that's actually the move before this. You want actually to take this off. And then here. And then here. And then now you can take this off. There's some stuff with consecutive ones that I think I'm not understanding. And I'm adding zeros and that makes it easier. But let's say I have just ones. What am I doing? Right? Well, here it goes to, if nothing else, this is one move, and then now you can remove this, and then now you can remove do this, and then now you can remove the suffix, right? Right? And then do this. I guess that's okay, but what if you have odd numbers, right? So let's say you have this instead of your input. Okay. So then now again you match. I guess you just do this. Is that right? Let me play around with this form, with this idea of matching ones. Okay, so what if you have something like a 0 here, or even just a 0 here? What do we do? Okay, first we can even these out. In one operation, and then you do, okay, fine. Now you have this, you can take this out. Okay, I guess that, then you don't even, okay, fine. Okay, I think I see the pattern, but I feel like I don't have a good understanding of it. So maybe we'll have to read up some answers later. So, okay, so okay, so then now moves is equal to 0, right? Let's just say we made it into a string. No, well, let's just make it into a bit thing, right? So, okay, fine. Bits, right? You can write in a number of ways. While n is greater than 0. This is pretty hard. I don't know if I can. I don't know if I can explain this one, to be honest. If it's right, if it's wrong, then I definitely can't. Right? Okay. So then now, okay, for I in range of length of bits, right? If bits of I is equal to 1. And bits of I plus 1 is equal to 0, then we just remove this thing, right? Oh, let's just do this, right? If I plus 1 is greater than or equal to n, or this, then now we just remove the suffix, because we assume everything we've seen before is zeros, right? So then now moves be added to 2 to the power of I minus 1, maybe? Right? So 1, yeah, 2, okay, fine. Right? And then else, if it's a 0, we just ignore, right? But then there's an else of, if this is a 1, then we take one move to set I plus 1 is equal to 0. Oh, and then maybe I should change this a little bit, right? So if bits of I plus 1 is equal to 1, maybe this logic is a little bit easier, right? Then we take one move, we set it to 0, and then else, after that we zero this out too. Right? Alright. Whatever. So we make one move to, so you have 1, 1, you take one move, okay? And then 2 to the 0, oh, this is 0, I forget, whoops. Okay, fine. The first digit should be plus 1, okay. And this, what, no? I is 0. Oh, I see. No, I mean, do I see? So for 1, you just make one move, right? Isn't this 2 to the 1? I'm looking at the right case. Why is it returning 4? Let me double check some stuff. Okay, now that's what I expect. So okay, if it's equal to 1, and the next one is a 1, which it is, it moves equal to 1. I plus 1 is equal to 0, and then this never happens, right? What is going on? This is pretty hard. I don't know if I can explain this, to be honest, even if this ends up being right. Even though I'm obviously still struggling. But why is this, I thought we set this to be 0. Oh, This is not N, this is length of bits. And this is what happens when I mix stuff. Okay. I'm just banging on the keyboard. Oh, oops. Okay. So we definitely have something wrong. So that's good, I guess. I mean, it's not great, but at least it's something. Somebody got this one right there. Why is this wrong? Need smaller cases. Okay, so I'm wrong for a lot of things. So, okay. So 10 is going to be 10, and we have 18, we expected 12. What is 10? 10 is this number, so yeah, we do expect 12. So what am I doing here? So 10, first we try to get this to be a 0. Oh. Yeah. So then how many moves does that take? That takes 3 moves. So now 3 moves later, we're here. Is that true? Is that true? Yeah, 1, 2, 3, right? But then why do I have this thing is just like really weird then. Oh no. We wouldn't get from here to here and then subtract this off. Okay, so this is very weird for me. Or maybe it's not weird, but it's just okay. Now what? Now how did I get 12 from here? Was that, and my logic was that here. Oh, here we can. Maybe I missed a step. I did miss a step. I think I missed a little bit in the understanding, because basically, so we have something like this. I was just saying that you can take off the end, like first I'll take this and this, right? But here already, you don't just remove this. Oh, well, let's say this is already a 0. Then what, right? You remove this by, well, you have to set the next one to 1 and then remove this. So yeah, so now you set the next one to 1 and then you remove this. And then now you can set this one to 0 and then you remove this. No, that doesn't make sense. How do you get rid of this suffix again? Do you get, okay, here you definitely want to get rid of the suffix, but actually, right, and the form is right. But, like for example, here you wouldn't get rid of the suffix, you would get rid of the prefix, right? So what happens if you have a z? So maybe my 0 case is wrong. If the next number is a 0, you remove it. You set it to a 1. you set it to a 1, like, okay, from here you want to go to here by making one move and then get rid of the 10 and then the suffix. Okay. So that means that if you have a 1, but the next bit is a 0, does that make sense? So I was doing it the other way actually. Something like this. I go, well, I have something like this. I go doop, 0, boop, and then now we have 1,000. But that's not, that's what I guess that's the odd number case that I was wrong about. The even number case I think is fine and makes sense, right? So let's say you have 10, okay. Hey, well, I guess that's not even, but let's say we have 14, right? Like 14, is that right? Like, is my test case right? No, because basically you have these ones. You set this one to be a 0 when you should be setting this one to be a 0. I think I'm just trying too hard to pattern match. I think I need to kind of go back to first principles and kind of restart the thinking a little bit. The idea should be that if we're doing first principle, the idea should be that if, okay, you take the first 2 bits, the most significant bits, and they should look like this. So no matter what it is, you should convert this to here, and then remove the most significant bit, and then here is just, we have an answer for that one. Okay. And if the first 2 bits look like this, then you still convert it to this, right? And then is the math just to kind of figure out how to get to there? Because here it is just, yeah. If we go from left to right, okay, we look at the first 2 bits, fine. And then now this, what does that mean? That means that we have to convert this to a 0, and we can convert this to a 0 by looking at the last 2 bits, and then convert these to zeros, right? And these we can do it the way that we've been doing. We'll do and then now, so and then now we go to somehow by flipping this bit. How much effort is there to get this one in? Okay, let's say we have this, and now we how much effort is there to take this one and move it here? What's the math on that? The math is, yeah, I mean, you obviously have to get it here, and then now how do you get to here? By getting to so that we can, so something like this, and then now you have so this, you flip. How many is that? like for example here, you actually don't try to go to 1,000, right? Trying to go to 1,100. So basically, the next thing makes sense. Okay. Let's say something like this. So you're trying to go here, and you go to here by. I mean, this is also just equivalent to converting this to 0, right? So then now we're solving for this one to zeros. And in this one, we're converting it to I mean, we want to convert this to here, but and here, how do we solve this? Well, we're trying to get to right? And we get to here by going to and we get to here by, man, I am just very lost today. I think I'm just trying to figure out how to get the math from here to say here even. Like, how do you solve this in a structural way? I mean, we could get to here, okay, fine. Or even here, depending how you want to say it, fine. But how? What is the recursion, right? And is this right? It's always on days that you're trying to get a quick finish. That I need to plug in my power soon. Like, okay, let's say we have this, right? Well, even we have this, right? So what does this mean? This means converting it to this. And then going to and then convert this to 0, right? What does that mean? That means that if we have this, we're trying to basically subtract out. We take moves to go to, well, let's do one at a time, right? Maybe, is it, which direction am I going? So you, okay. Okay, so let's say recursively, when we want to get to here, well, we want to get to here, so that means that we have to get to here, and to get to here, we have to go to here maybe, and to get to here, we have to go to there, and then we have to go here. So there is some like prefix thing going, right? In that you're trying to go to here, and so you're trying to go, well, this is just the initial. So you're trying to go here, and then here, and then here. In a way, you are taking like, but then you're getting to here, not this, which is what I guess I am wrong on. What's 15, 14 again? 14 is right, and I'm trying to get to, so then first I'm trying to get to here. Well, I guess I'm already here, so then now I'm trying to get to here. And then I'm just one move from here, right? There is like a prefix E thing to do, but I'm not quite to calculate where this lies, maybe I'm just going to have to figure out a pattern to it, right? I mean, I don't know, because whatever I'm doing isn't working, right? So yeah, so this has 4, right? And halfway, this is this, all right? And this is going to be 8. Halfway is this, is that right? That actually is not what I would have expected, maybe. And here, the 2, I guess, just matches. Yeah, I guess I have to really brute force it. I also need to get a power supply soon, so I might pause for a second. What is the prefix that this goes? I mean, this is just this for 1 and before, right? No, that's not true. That's an extra 0, so then now it's going to do, right? So is this shifted by 1 on the most significant bit? Whatever. Right? And this goes to right? Well, no. This goes to here. By the, yeah. This pattern is less obvious to me. Right? Why am I adding stuff? Hang on. Oh, no, it's this. And then now you're trying to get rid of the 100. So it's not, okay. I see. Because here you have to, so then now this is in reverse, trying to get rid of the 100. This is ridiculous. Okay, fine. I'm gonna pause for 2 seconds because I need to get my power supply to plug in. I didn't expect this one to be this short, to be frank. Sorry, friends. I don't even think I have a good explanation. But right. Try to not show you that I'm not wearing pants. I'm just kidding, but I'll be right back. Yeah. Alright, just have to get my power supply. I was just charging my my phone. I was too lazy to break out 2 power supplies earlier. Okay, I think now I see the pattern, but wow, that is a tough pattern, right? So the pattern isn't what I thought it would be, but basically, okay, what is the pattern, right? So basically here so there's the symmetry is that if you kind of draw it in a different way, right? And then here, if you kind of reverse this to right? So that's basically the pattern, is that, and then now you go to the 1000, which is here, say, and of course you can draw it in the other way if you like. Right, and then now you do the same thing for hundreds. Okay. And then you can kind of see that we can do 1 bit at a time, and this takes, 2 to the I or whatever it is, give or take, right? Okay, so then now the question is, what happens? Okay, so if we're at 10,000 and we're at 11,000 or whatever in binary, that's good and fine. How do you go from here to like, let's say we're here, how do you solve it, right? Like, what's the answer for 10, like for that number? I guess there are a couple of ways you could say it. You could go to the left to 10,000, like, and then subtract the difference or whatever, right? So this number is just equal to, there is some symmetry in here, in this and that. So this is just equal to getting rid of 10, but from 10,000, right? So like the number of moves to get rid of the 10, the binary 10, would get you to 10,000, and you just subtract that from the number of moves to go forward from there. Okay, but can I generalize it a little bit better? What about this one? Same thing, but so we're trying to get rid of the 1, which is, I guess, easy in this case, but is there a more generalized way of doing it? Or thinking about it. Okay, this one, I guess maybe is okay. This one, we want to get rid of the 111. Maybe that is a easier way to think about it. Okay, we're trying to get rid of the 111, and then the 111, if we already have the map, which we don't. I mean, it's just this thing, really. Right, if we have the 111, then now we can, yeah, we go left to 10,000, fine. 111, we we, I don't know, also go left. So we get rid of 11 from 100. So we add 100 and then we subtract the 11. Okay, something like that, right? Maybe that's a little bit easier. Okay, let's think about what that would mean, right? Yeah, let's do it the other way. Just reverse this, just like Missy Elliott would say, right? And then now, okay. Maybe not even, we just count down. And then now basically, okay, so now we're 10,000, so we add 10,000. And then we subtract the rest, right? So then now, almost like what was it? Inclusive, exclusive, right? Does that have to be one? So then now you flip, right? And only if this is this is ridiculous. Hopefully I didn't. I actually should have tested some edge cases. I'm a little bit tired. How did I did it in previous years? That Larry is smart. Yeah, that is not understandable. Okay, so the prefix, I get it. Okay. Oh man, this is actually really cool. Wonder how long it change the first past Larry is smarter than I am. I'm getting old. Oh, gray code is the thing that I was thinking about. I forgot the name. I mean, there's a Hemming thing too, and Debuchy thing, but I mean, I guess this was the logic I was trying to think, but I don't know why I didn't just implement it like this. This is pretty cool though. I think the way that I did it today is not very cool. The first character is 0. Okay, then just return that. That's fine. The second character is 1. Then we can change. Yeah. That's basically what I was saying, but I don't today. So I don't think I quite got to doing it like this. Maybe I should have do the enumeration. I think that's what I was half going through, but I just had trouble kind of making that one extra step. Yeah, I don't know. I don't like the way that I did it today, to be honest. And I think I just, like I said, pattern matched a little bit. I think if I were to kind of explain it, yeah, I think that's okay. I'm going to end with this because I'm going to just do the explanation a little bit differently than what I just did. So yeah, but this is going to be linear time, constant space-ish, or linear space maybe, depending on what you say, because n is the size of the output and bits is the size of the input. I don't know that, but yeah, but I think the idea here is that okay. I mean, I think I basically have the same idea. I don't know that this code really conveys that, but basically here, for whatever this is, I just basically try to get to the previous number and or the next number depending on where the thing is. But it's always going to be okay. So this we go to the left by 111. So maybe another way to think about it. Maybe another way that I could rewrite this in a way that I think is more intuitive given what I had. It's something like, maybe the same. I didn't want to do it this way, but I guess okay, so this is a string, right? So then, no, I mean, I guess I could rewrite it, but I think I'm just gonna. But this ends up being the same thing as my 4-year-old solution anyway. So I think I'm going to explain this one and then I mean it's kind of what I was going for, and that's what comes out. That's what this reduces to. But yeah. Anyway, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.